Hey, welcome to The Explainer. Today we're going to talk about a huge, kind of hidden crisis that affects, well, every single one of us who uses the internet. See, we're running out of internet addresses.
All right, to really wrap your head around this, just imagine something for a second. What if the world just ran out of phone numbers? Like completely. No new phones, no new lines could be connected. Sounds impossible, right?
Well, believe it or not, that exact thing has been happening to the internet for more than a decade now. The original address system is basically tapped out, and that's forced us into one of the biggest and slowest upgrades in tech history. So, how on earth did we get here? Okay, so first things first, let's get the basics down. To really understand this whole crisis, you gotta know how any device, your phone, your laptop, even your smart toaster, actually gets an address and gets online in the first place. Every single thing that connects to the internet needs its own unique ID. It's called an Internet Protocol address or an IP address. The easiest way to think about it, it's just like a street address for your house. It's how all that data knows exactly where to go. So the system that's been the backbone of the internet for, well, pretty much its entire life is called Internet Protocol version 4. You'll hear it called IPv4. This thing went live way back in 1983 on the ARPANET, and it's literally the foundation of our entire digital world. And look, for a long time, IPv4 worked perfectly. But the folks who designed it back in the early 80s, how could they have ever predicted the absolute explosion of growth that was coming? A major flaw was kind of baked into the system from day one. It just wasn't big enough. Here it is. That's the magic number, roughly 4.3 billion. See, because of its 32-bit structure, that was the absolute maximum number of unique addresses IPv4 could ever create. Back in the early 80s, when you only had a few thousand computers online, 4.3 billion seemed like an infinite number. Turns out, it wasn't even close. Yeah, the world just grew way too fast for the system. First, you had the World Wide Web just exploding in the 90s. Then came always-on broadband. And then the real tidal wave, smartphones. Every single one of those devices needed its own address, and it just drained the pool way faster than anyone imagined. By 2011, the top authorities handed out the last major blocks. The well was officially dry.
Okay, so wait a minute. If we basically ran out of these addresses over a decade ago, why didn't the internet just stop working? That's the big question, right? The answer is a really clever but also really complicated workaround that bought us some time. But it came with a pretty big trade-off.
So to get this little trick, you have to know there are actually two kinds of IP addresses. You've got your public IP, that's the one the rest of the world sees. Think of it like the main street address for a big office building. But then you have private IPs. Those are all the internal addresses for the devices inside your network, like the specific cubicle number for each person. Your router is the thing that handles all the back and forth between them. This whole system is called Network Address Translation, or you'll just hear it called NAT, and it works kind of like a receptionist at that office building. Your entire home network with all your devices can share just one public IP address. The NAT system in your router is the smart part. It keeps track of which device made which request and makes sure the right information gets back to it. It was a brilliant hack to conserve addresses. But NAT, it came with a huge downside. It basically broke the original beautiful design of the internet. See, the internet was built on this idea of end-to-end connectivity, where any device could talk directly to any other device. NAT shoved this messy middleman right in the way. This is exactly why you sometimes have issues with online gaming or trying to connect to your home security camera when you're out. It just complicates things. But here's the thing. NAT was always just a Band-Aid. The real long-term fix has actually been in the works since the late 90s, and the scale of this solution is, well, it's just mind-boggling. This is the future of the internet. So, say hello to Internet Protocol version 6, or IPv6. The fundamental change is super simple, but the result is profound. While IPv4 used a 32-bit address, IPv6 uses a 128-bit one. Now, that doesn't just double the space. It expands it exponentially. It's a whole different ballgame. So how many addresses are we talking about? We're talking about that many. That's 340 undecillion. It's a number so ridiculously massive our brains can't even really process it. We've basically gone from a tiny little pond of addresses to an entire cosmic ocean of them. Let's try to put that in perspective. This is enough address space to give trillions with a T, of IP addresses to every single person on Earth. The problem of running out of addresses? With IPv6, it's gone. Forever. But IPv6 isn't just about having a ton more addresses. It was a chance to go back and fix some of the other quirks of IPv4. It brings back that beautiful, direct, end-to-end connection that NAT broke. It makes setting up new devices on a network way easier. And this is a big one. It makes key security features mandatory, not just an optional extra. All right, so if IPv6 is so much better, if it solves this massive problem and adds all these new features, that leads to the really obvious question, right? Why aren't we all using it already? And this is where we get to the heart of this huge global challenge. I mean, think about it. The standard for IPv6 was finalized way back in 1998. We've had the solution for decades, all while knowing the problem was just getting worse and worse. So what's the holdup? Why the delay? Well, it basically boils down to a classic chicken or egg problem. You have the internet service providers, the ISPs. They've been slow to upgrade their networks because, hey, there aren't enough websites and apps that actually require it. On the other side, you have the app developers, and they're hesitant to build for IPv6 because not enough of their users or the networks are ready for it. It's just a massive global stalemate. And on top of that stalemate, you've got other huge hurdles. The cost to upgrade all the hardware, the software, the training, it's enormous. Plus, and this is critical, IPv4 and IPv6 can't talk to each other directly. So for years, networks have to run both at the same time, which just adds a ton of complexity. And of course, anytime you do a transition this massive, everyone's worried about opening up new security holes. But here's the good news. Despite all of that, the transition is happening. It's just happening very, very slowly. It's kind of like trying to rebuild the entire foundation of a massive skyscraper while millions of people are still living and working inside it. It's slow, it's painstaking, but network by network, the internet is being rebuilt for the future. And that really leaves us with a final, fascinating question. As we slowly keep rebuilding the internet's foundation, what will a world with truly unlimited digital addresses actually look like? What new kinds of technologies, what new ways of connecting become possible when the internet can finally work the way its creators always dreamed it would? That future is being built right now, one network at a time.